Let's do one more quick example to solve this by factoring. You're going to look for the GCF. There is not one. It's a cube. Check to see if both terms are perfect cubes, and they are. So I had you identify the values of a and b, which would be the cube root of the first term, which would be x. Cube root of the second term would be 3. Open up a binomial times a trinomial, and this is equal to 0. The pattern says you put your a and your b here. You square a, you square b, which would be 9, and the product of a and b in the middle. Then you use SOAP, same, opposite, always positive to get your signs right. It's factored. This quadratic will not factor any further when it comes out of the sum or difference of two cubes. So you apply the ZPP. So the first is x minus 3 equals 0, or the second is x squared plus 3x plus 9 equals 0. The first gives me a solution of 3. The second one, how am I going to solve this? Well, fortunately, I have the quadratic formula that states that x is equal to negative b, which would be negative 3 plus or minus the square root, b squared, which would be 3 squared minus 4 times 1 times 9, all over 2 times 1 would be 2. So I'm going to find the value of my discriminant, which would be, let's see, 9 minus 36 would be negative 27 over 2. And I'm going to simplify the square root of negative 27. Just going to move this up. So this simplifies into, well, negative 27 would be negative 1 times 27, and then this would be 9 times 3, and 3 times 3. So this factors into negative 3 plus or minus. I have a pair of 3's, so 1 3 comes out. The square root of negative 1 is I, times the square root. I have 1 3 left inside, all over 2. So my three solutions would be that x equals 3, or negative 3 over 2 plus 3 halves I root 3, or negative 3 halves minus 3 halves I root 3. So it just changes to a minus. So bottom line is you got to go back to the good old quadratic formula to finish factoring this quadratic when you are doing the two cubes pattern to solve a to solve a polynomial equation.